why are you upset?
I've been oscillating in my boat for hours and can't go forward.
Ah, you should know about waves and its properties, then you can find how to go forward. A wave is a disturbance in a medium that carries energy without a net movement of particles. It may take the form of elastic deformation, a variation of pressure, electric or magnetic intensity, electric potential, or temperature. For example, ocean waves are a disturbance on the surface of the sea or ocean in the form of a moving ridge or swell. The size of a wave depends on its fetch. The fetch of a wave is the distance it travels. The greater the fetch, the larger the wave.
You mean I should use wind power to go ahead? Good idea.
Yes. Waves travel with little change across the vast expanses of the open ocean, but eventually all waves must reach shore. As a wave approaches the coast, it becomes shorter in length and more abrupt, increasing its height. Friction with the bottom causes the trough of the wave to disappear, the crest to slow its movement. And when the depth causes the wave height to become 1.3 times the water depth, the crest falls, forming a breaker. There are two types of waves that are most commonly studied in classical physics: mechanical waves and electromagnetic waves. In a mechanical wave, stress and strain fields oscillate about a mechanical equilibrium. A mechanical wave is a local deformation in some physical medium that propagates from particle to particle by creating local stresses that cause strain in neighboring particles too. For example, sound waves are variations of the local pressure and particle motion that propagate through the medium. In an electromagnetic wave, such as light, coupling between the electric and magnetic fields sustains propagation of waves involving these fields according to Maxwell's equations. We can begin to briefly describe the history of the wave equation starting with Johann Bernoulli when he solved the problem of the catenary which had been proposed by his brother Jacob in 1691. Around 1740, Leonhard Euler turned his attention to the exponential function and derived the equation named after him by comparing the series expansions of the exponential and trigonometric expressions. French mathematician Joseph Fourier discovered that sinusoidal waves can be summed as simple building blocks to approximate any periodic waveform, including square waves. These Fourier series are frequently used in signal processing and the statistical analysis of time series. Sine waves of arbitrary phase and amplitude are called sinusoids and have the general form: A is amplitude, the peak deviation of the function from zero. T is the real independent variable, usually representing time in seconds. Omega is angular frequency, the rate of change of the function argument in units of radians per second. F is ordinary frequency, the number of oscillations that occur each second of time. Phi is initial phase. The initial phase shift is zero, which means at time zero the wave elevation is zero and is on the rise. If we know the wavelength and frequency of a wave, we can work out its speed. Thank you for liking this video and subscribe our YouTube channel for the latest videos.